Now we're going to continue our discussion about solving indefinite integrals, and we're going to continue to use the process of U-substitution. So remember what we commonly said, we choose U, something to be in the power raised to a number, some expression under a radical, some expression in the denominator, all those situations, whatever we have inside those parentheses or the grouping mechanism, that is generally what we choose to be our U value. So in this example, we're dealing with the integral of theta times the fourth root of 1 minus theta squared d theta. So one thing that we often do is we take fourth roots or any sort of radical in calculus and we rewrite it as a rational power. So in this situation, now I see I have an expression here in a power. So that's going to be what we will let equal U. I'm going to say let U equal 1 minus theta squared. So when we're doing U substitution, we take the derivative. And in this case, we would say, well, the derivative of U with respect to theta equals negative 2 theta. The derivative of 1 is 0, and the derivative of theta squared is 2 theta. There's a minus in front of it. And so we've talked about, well, I need whatever is left in my integrand and considering my variable of integration, I need that exactly. So this expression that we're looking at, I need to rearrange it so that it looks like theta d theta, because that's what I have left. So this would be the same as du equals negative 2 theta if I multiply by d theta. And then I could divide by negative 2, so negative 1/2 du equals theta d theta. So now that I've done that, I can perform my substitution. I'll have U to the 1/4 power, and theta d theta is equal to negative 1/2 du. So I have times negative 1/2 du. Okay, at this point now, we can pull that negative 1/2 in front of our integral symbol, and I just need to integrate U to the 1/4 du. So the integral of U to the 1/4, remember we use our power rule, we're going to add 1 to that 1/4, that's U to the 5/4 divided by 5/4 plus C. So dividing by 5/4 is the same as multiplying by 4/5. So I have negative 4/10 U to the 5/4 plus C. So when I multiply negative 1/2 by 5/4, or by the reciprocal 4/5, I get negative 4/10. So that will reduce, and I have negative 2/5 U to the 5/4 plus C. And of course, depending on the problem, this 1/2, we may need to distribute, but we don't need to distribute a variable to C. We don't know what C is currently, so 1/2 of that arbitrary constant is still an arbitrary constant, so we still say plus C. We're not done with the problem yet because we started our problem with thetas. We want to end with thetas. So remember, we said that U is equal to 1 minus theta. So I'm going to come back down here and plug 1 minus theta in, and my answer is negative 2/5, the quantity, 1 minus theta squared. I'm sorry, that was 1 minus theta squared, right? 1 minus theta squared to the 5/4 plus C. And this is fine, in my opinion, as your final answer. But of course, if you want to put that radical form back in there, you could rewrite this and say -2, we have 4th root of 1 minus theta squared to the 5th over 5 plus c. So that's just an alternate form. And you just want to make sure that you're comfortable with your algebra skills so that rearranging our expressions or our functions in calculus isn't difficult for us. So let's do 2 more similar examples in this video. So our next example, here we're going to integrate r to the 4th times the quantity 7 minus r to the 5th divided by 10 raised to the 3rd power. And we're integrating with respect to r. Now, you don't necessarily have to solve this problem using U-substitution. You do have the option using algebra to multiply this, or to FOIL in a sense, 3 times. And then distribute that r to the 4th. So it's not, completely out of the question for you to multiply this all the way out and make it look like a polynomial and use your power rule, right? But that's going to be a lot of algebra. So what I would do is try to solve this using a U-substitution. And generally, whatever we have in the power, that's what we're going to let equal our U. So I'm going to come over here, I'm going to say, well, let U equals 7 minus 1/10 r to the 5th. And notice that divide by 10, that's the same as a coefficient of 1/10. So once we have that, then we take the derivative of u with respect to r. The derivative of 7 is 0, so that's going to go away. And the derivative of negative 1/10 r to the 5th is going to become negative 5/10 r to the 4th, and 5/10, that's the same as negative 1/2 r to the 4th. So looking at what I have left in my problem, I have r to the 4th and dr. So I need to make this look like one side of the equation is that r to the 4th dr. So what I'm going to do is say that du equals negative 1/2 r to the 4th dr. Multiplied by 1/2, we have negative 2 du is r to the 4th dr. So simplifying this integral, my parentheses, I have u now to the 3rd power, and r to the 4th dr, r to the 4th dr is equal to negative 2 du. So this is negative 2, the integral of u cubed du. That's very easy for us to integrate. That becomes negative 2 u to the 4th over 4 plus c. Distribute that negative 2, and I have negative 1/2 u to the 4th plus c. At this point, all I need to do is to plug my expression back in for u, and u is equal to 7 minus r to the 5th over 10. So my final answer here is negative 1/2 7 minus r to the 5th over 10, all of which is raised to the 4th power plus c. So hopefully you're starting to get the hang of U-substitution and determining how to choose your u value. Let's do one more example in this video. So here we have the integral 1 over x squared times the square root of the quantity 2 minus 1 divided by x, integrating with respect to x. So the first thing we often do when we're dealing with problems with square roots, remember we want to turn those into rational powers. So this is the same as 2 minus 1 over x to the 1/2 dx. And, you know, it's all about being comfortable with your manipulation. So if I wanted to, I could write that as x to the negative 2. 1 over x squared is x to the negative 2. And 1 over x could be rewritten as x to the negative 1. All right, so if I rewrite it like that, then I see, well, it might be easy for me to say, let's let u equal 2 minus x to the negative 1. So now, if I differentiate u with respect to x, 2 becomes 0, and I have negative 1x minus 2 to the negative 2 power. So du equals x to the negative 2 dx, which I see in my problem. So this is the integral of u to the 1/2 power and x to the negative 2 dx, that's equal to du. So again, this is a very easy integration. In this case, adding 1 to 1/2, that gives me u to the 3/2 divided by 3/2 plus c. So again, that's the same as 2/3. Dividing by 3/2 is the same as multiplying by the reciprocal. Plus c. So almost done. We just need to plug our u value back in, and u is 2 minus x to the negative 1. So I have 2/3, 2 minus x to the negative 1 to the 3/2 plus c. And if we want to, x to the negative 1, that's the same as 1 over x. So this is my final answer. I just changed it back to 1 over x to make it look as though or similar to what it did in the original problem. And, you know, also I could take that square root, and this would also be a similar answer. 2/3, that would be the square root of 2 minus 1 over x cubed plus c. All right, so just pay attention when you're entering your answers on the computer, and remember that the general rule is to return the answer in a format similar to which it was given. So we've done 3 examples using U-substitution with square roots or something in parentheses raised to a power, because we can always turn a square root or 4th root radical into a power.